right, guys, sorry, I got interrupted there. Let's keep on doing our double and triple bonds here. Okay, so next thing, we're gonna look at sulfur dioxide. So we need to look at sulfur and we need to look at oxygen. So if I look at sulfur, it also has 6 valence electrons, just like oxygen. So let's put that in here. So sulfur has 6 valence electrons and oxygen has 6 as well. I've got 2 oxygens, so I'm going to multiply my oxygen by 2. This gives me a grand total of 18 valence electrons. Okay, so sulfur is also further away than oxygen is from fluorine. So we're going to put sulfur in the middle. Okay, so let's put sulfur in the middle. And we're going to put a single bond to each of the oxygens. And if I do that, the oxygens have 1 bond, so they have 2 electrons. So I'm going to put 3 lone pairs around the oxygens to give them a total of 8. The sulfur has 2 bonds, so it has 4 electrons that it can use. So I'm going to put 2 lone pairs on the sulfur to satisfy its octet. Now, if you were counting, we actually used up 2, 4, 6, 8, 10, 12, 14, 15, 16, 18, 20 electrons. That's 2 more than we actually have. So we've got to save 2, and we could save 2 electrons by putting in a double bond. So let's put in a double bond. I'm going to put sulfur in the middle, put 1 oxygen with a double bond. So that oxygen already has 4 electrons, so it needs 4 more to satisfy its octet. Then I'll put a single bond on this oxygen. It has 1 bond, so it's going to need 3 lone pairs to satisfy its octet. And the sulfur has access to 2 electrons here on the right and 4 electrons from the 2 bonds here on the left. So it has 6 electrons. It needs 2 more to satisfy its octet. So if I do that and I count up my electrons that I've used 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons, which is indeed the amount of electrons that I have. Okay, now the next question becomes, does it really matter which side I put that double bond on? No, it really doesn't matter. You could put it on either side. Okay, now that center atom, that sulfur, let's look at the amount of bonding areas it has and the amount of lone pairs areas. Now remember, double bonds are counted as 1 bonding area. So I have 2 bonding areas and I have 1 lone pair area. Okay, so that will be really important when we start looking at shape here in a couple of next time. Let's look at sulfur trioxide. Now, sulfur trioxide, and I need more space. So sulfur trioxide, sulfur has 6 valence electrons. And oxygen also has 6 valence electrons, but I've got 3. So I'm going to multiply that by 3. So 6 times 3 is 18, plus the 6 of the sulfur will give me 24. Okay? So let's put sulfur in the middle, just like we did before. I'm going to draw single bonds to each of the oxygens. And because oxygen, they have a bond already, they have access to 2 electrons. So I'm going to need 3 lone pairs on each of these oxygens. Okay, so that will satisfy oxygen's octet. Now let's look at sulfur. Sulfur has access to 1, 2, 3 bonds. That gives it 6 electrons. So it needs a lone pair also. Now, if I look at this, let's see, let's count my electrons. I've used 2, 4, 6, 8 electrons on that oxygen. These oxygens are all the same. So this one's 8 more here and 8 more here. So that gives me 24 plus that lone pair. That gives me 26. That's 2 more than I actually have. So I need to save 2 electrons. And I can do that by putting in 1 double bond. Does it really matter which oxygen I put it in? No, not really. So I'm going to put in a double bond on one of the oxygens. So that oxygen, to have a full octet, will need 2 lone pairs to have 8. And then the other 2 oxygens are going to be single bonded with 3 lone pairs to have their octets. Okay, so let's count my electrons that I have used here. So I've used 2, 4, 6, 8 electrons here. I've used 8 more on this oxygen as well, so I'm up to 16. I've used 2, 4, 6, 8 on this one as well. So I've used the 24 electrons. 8, 8, and 8 is 24. So this is my Lewis structure for sulfur trioxide. Now let's look at that center sulfur. We have 3 bonding areas. 2 are single bonds and 1 is a double bond. So we have 3 bonding areas. And we have 0 lone pair areas on that. Okay, now let's do nitrogen. Let's see. Nitrogen is also what we call diatomic because it comes in groups of 2. Nitrogen, we have 5 valence electrons here with nitrogen. And I've got 2 nitrogens. So I've got 5. Let's do this, and let's make this even thinner. So I've got 5 valence electrons with that nitrogen. I've got 2 of them, so I'm going to multiply it by 2. So 5 times 2 will give me 10 total. That's what I'm shooting for. Okay, now you should realize that there is a pattern here. Up here we had 10 valence electrons, and over here we also had 10 valence electrons, and we had to put in triple bonds. So let's see, does that pattern hold true? Should we try it? Let's try it. Okay, I'm going to put in that triple bond. That means the nitrogen on the left has 6 electrons, so it's going to need a lone pair to get its 8. And the nitrogen on the right also has 6 electrons. It's also going to need a lone pair to get its octet. So if I count up my electrons that I've used 2, 4, 6, 8, 10. So indeed, nitrogen is triple bound. It's got a triple bond on that nitrogen. And that triple bond on nitrogen is why we as human beings can't break it down. That's why we are dependent on bacteria in the soil to get nitrogen into the plant material so that we can actually process it. Okay, last but not least on here, we've got ozone. So ozone is 3 oxygens. So oxygen, this really doesn't want to write. Oxygen has 6 valence electrons, and I've got 3 of them. So 6 times 3 is 18. Okay, so oxygen has to be in the middle. There's no other way because all I have is oxygen. So if I do single bonds, the oxygen on the left and the oxygen on the right only have 1 bond, so they need 3 lone pairs to satisfy their octets. Okay, and then the oxygen in the middle has 2 bonds, so it's got 4 electrons, so it needs 2 lone pairs to satisfy its octet. Now, if we count up all the electrons that we have used, we've used 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. We've used 20. We only have 18 to use. So I need to put a double bond in. Now, once again, does it matter which side I put it in? No. I can put it on the right or the left. It really doesn't matter. Now, the double bond oxygen here on the right already has 4 electrons from the 2 bonds, so I had to put on 2 lone pairs to satisfy its octet. The oxygen here on the left is single bonded, so I needed to put in 3 lone pairs to satisfy its octet. Now, the oxygen here in the middle has a single bond and it has a single bond and a double bond. So it has 3 bonds, so 6 electrons. So it needs 1 lone pair. Now, when I count up the electrons here that I have used, I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, which is exactly the amount I have. So ozone, or O3, that is the Lewis structure. Okay? So this center atom, let's look at this center atom. I've got 2 bonding areas. So I've got 2 bonding areas. And I've got 1 lone pair area. Okay? So let's do our next set here. We're going to talk about doing Lewis structures with ions. Okay? So let's talk about ions. We've talked about them before. Ions are atoms or groups of atoms. We can have multiple atoms together that have a charge. It just means having a charge means that the number of protons does not equal the number of electrons. Okay? So positive ions are created by losing electrons. Remember, electrons are negative. So if by the loss, let's do the loss so it's grammatically correct. Positive ions are created by the loss of electrons or losing electrons, okay? Negative ions are created by the gain of electrons. So if I have extra electrons, I get a negative charge, okay? When calculating valence electrons for ions, we subtract electrons for positive ions, and we add electrons for the negative ions. Now, we add the number that the charge indicates, okay? Traditionally, brackets are placed around Lewis structures for ions with a charge placed in the upper right-hand corner outside the brackets. So we're going to try a few, okay? So we have NO2 negative. That negative means that there's 1 negative. So when I look at this, let's see. This is the nitrite ion. So if I look at nitrogen, I've got 5 valence electrons, and oxygen gives me 6 valence electrons. So I'm going to put that there. So nitrogen gives me 5, oxygen gives me 6, and I've got 2 of them, and then I've got that -1 charge. So I'm going to add in 1 more. So 5 plus 12 is 17, plus 1 more is 18. So my grand total here will be 18 valence electrons that I need to place. Now the next thing I need to decide is what's going to be the middle. So if I look at nitrogen and oxygen, nitrogen is not as close as oxygen is to fluorine. So nitrogen we're going to put in the middle. So I'm going to put nitrogen in the middle, and I'll put single bonds to each of those oxygens. Now, if I fill up their octets, The oxygen is going to need 3 lone pairs. This oxygen will need 3 lone pairs. And nitrogen has 2 bonds to it, so it's going to need 2 lone pairs. Okay? Now, if you count all the electrons that I've put in there, I've used 20, and I only have 18. So we know that we need to save 1 pair of electrons, or 2 electrons. So I know I need to put in a double bond. Now, it doesn't really matter which side I put that double bond on. Okay, I can put it on either the right side or the left side. The oxygen on the left with the double bond is going to need 2 lone pairs to satisfy its octet. It's 2, 4, 6, 8 electrons there. The oxygen on the right is going to need 3 lone pairs to satisfy its octet. So that will give me 2, 4, 6, 8 electrons on that oxygen. The nitrogen has 2, 4, 6 electrons already from the bonds. It needs 2 more for its octet. Now, I have used, let's see, 2, 4, 6, 8, 10, 12, 13, 14, 16, 18 electrons. So that is indeed the Lewis structure. So I'm going to put a bracket here, and I'm going to put the charge of -1. You can just put a negative, meaning -1, or you can actually mark it -1. Okay? Now, around this center atom of nitrogen, we have 2 bonding areas. So we have 2 bonding areas, and we have 1 lone pair. Okay? Let's look at ammonium. So, wow, what is this doing? On ammonium, nitrogen has 5 valence electrons and hydrogen has 1. So we're going to write this out. Nitrogen has 5, hydrogen has 1, but we've got 4 hydrogens. So I'm going to multiply this by 4. And then I have a positive charge, which means I'm going to subtract an electron. So let's see, 1 times 4 is 4, plus 5 is 9, minus 1 gives me 8 valence electrons total. Okay? Nitrogen is going to be in the middle because hydrogen can't, right? I'm going to draw a single bond to each of the hydrogens. Okay? Now, each of these hydrogens has access to 2 electrons. And remember, hydrogen can only do 2 electrons. So hydrogen's full. Nitrogen has 4 single bonds around it, which gives it 8 electrons. So that's satisfied that octet, and I have used the 8 electrons. So that is the Lewis structure right there. We're going to close it up with the bracket and put the charge. Okay, phosphate. Here we go. Phosphorus has 5 valence electrons. Oxygen has 6. So let's do this. Phosphorus has 5. Oxygen has 6, and I'm going to times it by 4 because I've got 4 oxygens. And the charge, I'm going to add 3 more valence electrons. So 5 plus 24 is 29, plus 3 more is 32. So I have 32 valence electrons. Okay, so I'm going to put phosphorus in the middle. I'm going to do single bonds to each of the oxygens. Now, let's look at the oxygens. They have 1 bond, so they need 3 lone pairs to satisfy their octet to get them 8 electrons. So I'm going to put 3 lone pairs on each of these oxygens to satisfy their octets. And phosphorus has 4 single bonds with 2 electrons each, so its octet is already satisfied. Now let's see what we have done with our electrons. So if I count up my electrons, I've got 2, 4, 6, 8 electrons on each of those oxygens, right? They're all the same. Let's see, 4 times 8 is 32. So I have used up all 32 of my electrons. So that is indeed the structure. And we'll put the charge on the outside. Okay, so there's the phosphate ion. Now for the chlorate ion. We need to look at chlorine. Chlorine has 7 valence electrons. Oxygen has 6. So chlorine has 7 valence electrons, oxygen has 6, and I've got 3 of them, so I'm going to multiply that by 3, and I've got this charge of -1. So I'm going to add in 1 more electron. So 6 times 3 is 18, plus 7 is 25, plus 1 more is 26. So I get 26 valence electrons. Now, oxygen is more electronegative than chlorine. So we're going to put chlorine in the middle. We're going to put chlorine in the middle, and we're going to put a single bond to each of the 3 oxygens. Now that single bond gives the oxygens 2 electrons. So they need 3 lone pairs to satisfy their octet. So I'm going to put 3 lone pairs on each of these oxygens to satisfy their octets. Okay? Now chlorine in the middle has 3 bonds to it, so that will give me 6 electrons. So chlorine needs a lone pair to satisfy its octet. Now, when I look at this, I have used all 26 of my electrons. So each of the oxygens have, let's count them up. Each of the oxygens, is it going to let me change to pink? Okay. Has 2, 4, 6, 8 electrons. 8 times 3 is 24, plus the 2 that I put here on top gives me the 26 valence electrons. So the last thing I need to do is close it off with brackets and put the charge on the upper right-hand side. Okay, so hopefully you're feeling a little more comfortable with this. Now, I want you to try and do some of these next ones on your own, and we'll check in just a minute. Okay, so take a minute, check in. Okay. All right, hydroxide. Oxygen has 6 valence electrons and hydrogen has 1. So oxygen has 6, hydrogen has 1, and I've got that charge, so I'm going to add in 1 more. So that gives me 8 total. Now there's no center atom here. The oxygen is going to need 3 more lone pairs. And so the oxygen is satisfied, the hydrogen is satisfied because it can only do 2, and I have used all 8 of my electrons. So there's my hydroxide. That's the hydroxide. Oh, and you know what? Let's go back to this last one. I did not do the center atom. Let's talk about that center atom of chlorine. Chlorine has 3 bonding areas. So I have 3 bonding areas here. And I have 1 lone pair area. Okay? All right. Let's go back to our next one. Okay, sulfate. So if I look at sulfur, sulfur has 6 valence electrons and oxygen also has 6. So sulfur has 6, oxygen has 6, and I've got 4 oxygens, and that -2 charge gives me 2 extra electrons. So let's add it up. 6 plus 24, 6 times 4 is 24. 6 plus 24 is 30 plus 32. That gives me 32. Now sulfur is going to be in the middle. Okay. Sulfur. Oh, wow. Gonna let me erase? Erase. Okay. Hopefully now it will let me draw. So sulfur is going to be in the middle because it is less electronegative than oxygen. Each of these oxygens have one bond, so I'm going to need to put 3 lone pairs to satisfy their octets on each of these oxygens. Okay, 3 lone pairs on each of those oxygens. And sulfur has 4 bonds to it, so it also has 8 electrons. Now let's look at each of these oxygens. I've got 8 electrons around each of these oxygens. So 8, and they're all the same. So 8 times 1, 2, 3, 4 gives me 32. So, yep, I've used my 32 electrons. I'm going to bracket this up, and I'm going to put the charge on the outside. Okay? This center atom, the sulfur, has 4 bonding areas and 0 lone pairs. Okay? Bromine. Let's look at bromine. So this is the bromide ion. We have 7 valence electrons for bromine and 6 for oxygen. So bromine gives me 7 valence electrons, and oxygen gives me 6, and I've got 3 of them, and I've got a charge of -1, so I'm going to add in 1 more electron. So let's see, 6 times 3 is 18, plus 7 is 25, plus 1 more is 26. So I have 26 valence electrons total. Bromine is going to be in the middle. I'm going to do single bonds to each of the oxygens. So each of the oxygens have 2 electrons in that bond, so they need 3 lone pairs to satisfy their octets. So I'm going to put in the 3 lone pairs to satisfy their octet. Bromine has 3 bonds, so it has 6 electrons, so I need 1 lone pair. Well, that lone pair really got away from me there. Is it going to let me erase? There we go. Okay, so on each of these oxygens, I have 8 electrons. So 8 times 3 is 24, plus the lone pair on the top of this bromine gives me 26. So I have indeed used my 26 electrons. I'm going to bracket that up, put the charge. Now on this center atom, I've got 3 bonding areas. And I've got 1 right here, that 1 lone pair. Okay? And then last but not least, the sulfite ion. Okay? Sulfur has 6 valence electrons. Oxygen has 6 valence electrons, and I've got 3 of them, and I've got 2 more electrons because of that charge. So 6 plus 18 is 24, plus 2 more is 26. What do you think? This is the same amount of electrons. Do you think it's going to have the same structure? Should we try it? So sulfur is going to be in the middle. I need 3 lone pairs around each of these oxygens to satisfy their octet with their single bonds. So 1 single bond plus 3 lone pairs equals 8 for an octet. The sulfur has 3 bonds, so it needs 1 lone pair to get its octet. I have indeed used 26 electrons. So this is my Lewis structure for my sulfate or my sulfite ion. Okay? All right. We will start layering in shapes next time. So we're going to start determining shapes, and that's why these lone pairs of bonding areas will come to be so important next time. Have a great time. We'll talk to you later. Bye.